This is the first assignment for the Digital Signal Processing class, EEL 4750. We use digital signal processing in different fields of study. For example, computer vision, voice recognition, and radars, and different fields. I am going to analyze the case of projectile motion that we use in the experimental physics lab to teach the basics of motion. So this is a tick timer that we use in the lab, and it has different frequencies. Sometimes it's 50 Hz, but some of them can be changed to 10 Hz or 40 Hz. So it can be arranged. For example, if we set 10 Hz, that means in 1 second it's going to do 10 dots. If we choose 40 Hz, it's going to make 40 dots in 1 second. So we're going to take a discrete time measurement. The tick timer can be attached to an object that's going to move, and it's going to make dots on the tape, as shown in here. For example, if we choose 10 Hz, the tick timer is going to do 10 dots each second. If we see this tape, the distance between the dots is equal, so it's equidistant. That means that the velocity is constant and acceleration is equal to 0. For the next case, we have the same frequency, but we see that the distance between the dots is every time larger. This means that the object speed is increasing and acceleration is not longer 0. For this case, we see that the distance between the dots every time is shorter. So in this case, the speed is decreasing and the acceleration is not 0. Now, we are going to analyze the case of projectile motion with discrete time. So now we consider that I'm going to play basketball and I'm going to toss the basketball ball at an angle. The initial position of the ball at the level of my hands, and the initial velocity in the y direction is going to be 10 meters per second. We will do a table and a graph for the position function, the kinematic equation, for 2 seconds. The time interval is going to be 2 seconds of the experiment, and I'm going to use discrete time with different frequencies. So we see the ball, and the green arrow represents the initial velocity. You see that it was tossed at an angle, can be broken into components, the x component and the y component. X component is going to be constant since we are neglecting the air resistance, and the y component is going to be 10 meters per second since the air resistance is neglected. And I am going to use the kinematic equations, position function, to analyze the y direction. So as you can see, our y velocity, y component of velocity is 10 meters per second, and our initial position is going to be 0. We set that position to 0. I'm going to insert this function into my Excel spreadsheet and run the equation for the time of 2 seconds. So we have our initial conditions, and I chose 1 Hz. So this means that the tick timer is going to do 1 sample each second. As you can see, when the motion sensor detects the position, it records where the ball is in the y direction. In this graph, the y-axis represents the position in meters, and the x-axis represents the time in seconds. Remember, the experiment only has a duration of 2 seconds. So now this is the actual values. I'm going to trace like a line to make it like more visual, and you see where they are. Now I chose 2 Hz. This means that every second I have 2 samples. Now I'm going to trace a blue line to have like a more visual of what we are doing. With 3 Hz, we see that we have like a better resolution. We have more information, and we have a better idea of how it's going to be. This is with the line, and we see that's like a parabola. We can see that parabola is coming from this. I chose 5 Hz. So that means that each second I'm going to have 5 samples. And I see that's even closer. It's getting better, like more resolution. Let's see what happened with 10 Hz. This means that every second I have 10 samples. It's even better. You can see, and 40 Hz, I have much better approximation. I trace the line, and you can see. Now let's see the comparison between 1 Hz, 2 Hz, and 40 Hz. we see that the more samples we take, the better fit we get to this parabola that represents the position function of the ball in the y direction. Remember, the y-axis of these graphs represent position in meters, and the x-axis of these graphs represent time in seconds. So I hope this case was interesting. This is a common case we use in the physics lab to analyze motion, velocity, acceleration. Sometimes we use the tick timers, and other times, for this case, we use the motion detector that also takes samples. It's like the same concept of the tick timer. It takes samples with a certain frequency, and we can analyze a motion in different range of frequencies. Thank you, and I hope this was enjoyable. See you next time, guys.